Hello, Mustangs. So, on Friday, when we were all together, we went through how to go through protein synthesis. So, just a little review here before we go on to the next portion is that we start with DNA in the nucleus. DNA can't leave the nucleus. Those were the little blue cards that were on the table. And so in order for you to take that information outside of the table or outside of the nucleus, you had to write it down. Okay, and you were supposed to write it down not in DNA, but to copy it into messenger RNA or mRNA, and that process is called transcription. Once you have recorded your message into messenger RNA, then you were able to take that piece of paper and go around and find some matching pairs. So the messenger RNA, if we remember, is read 3 letters at a time. That is called the codon. All right. And so now we have to change the messenger RNA into the language of proteins. And now that I'm doing my video, I see that I've spelled proteins wrong, so don't judge me. Okay, so messenger RNA has to be converted into amino acids, which is what the building blocks of protein are. And in order to do that, we had to take messenger RNA and we had to code it into the anticodon, which is found on transfer RNAs. The transfer RNAs were scattered around the classroom on the cards on the wall. And on the back of the transfer RNAs were the amino acids or the sentences. And so we made the cheesy little sentences like we all have dog breath and your mother wears a rubber band and some of those other bad sentences. Okay, so we put words together to form sentences. DNA will give us the instructions on how to put amino acids together to form proteins. Okay, so we're going to continue to work kind of on this idea, but we have DNA. Okay, remember that DNA going into the messenger RNA. So the G is going to go down to the C. G codes with C. With messenger RNA, or with RNA in general, there is no T. And so what we see then is that it changes to the U. Okay. Again, we wrote this information down. The information got changed back into transfer RNA. Again, what we see is we still have the U's present. So that's a big sign about what language are we in. Are we in DNA? Where we see all the T's, or are we in RNA? And we know we're in RNA because we have the U's present. Okay, from the RNA, we go to the back of the cards where we find the words. The dog ate something. Okay, so from there now, what we're going to do is we're going to now learn about something called the messenger RNA table. Okay. This table is written in messenger RNA. And so if we take a look, we can see over on the left over here, we see the letters of RNA, which are U, C, A, and G. We see across the top the same letters, okay? And we see down the other side the same letters that are repeated over and over and over again. Okay, this should be exciting because what this does is this is going to allow us to convert our letters less often. Okay, so because this information is written in messenger RNA, what we need to do now is go only from DNA into messenger RNA, and then we can go straight to the table. Okay, all right, so let's take a look at a DNA or a strand. Okay, this is written in messenger RNA. Okay, so I have already gone from DNA into messenger RNA. I have only changed this one time. Okay, I am going to go through, and remember we always read 3 letters at a time. So there's one codon, CAU. Our second codon is GGC. Our third codon is ACG, and then UAA. All right, the way that this works is that we will take the first letter, which is C. All right, so I will go down to my first position of the codon right here, and I will find the letter C. Okay, my second letter is A, so now I'm up on the top row, and I will find the letter A. Okay. All right, now it's just like using a map, where if you wanted to know where 18th Street South was, you would go to a map and it would say go to E6. So you would go to E, and then you would go to 6, and you are going to draw your fingers until you come to that one little square, and it should be within that area. So we will do the same thing here. We're going to go with C, so I know I'm in this row. Okay. Now I'm going to go to A, and I know that I'm in this row. Okay, so the question is, where do the two intersect? It happens to be in this section. Okay, so now I have to take into consideration the third letter. The third letter is U. U, in this section that intersects with each other, is located in the top position. So I follow the U over, and the amino acid is called histidine. Okay, now these are real names of amino acids. Don't worry, you do not have to memorize them. But what I would do is underneath that is I would write the first three letters of that amino acid, which is his. All right, but that stands for histidine. All right, now we're going to do the next set. Okay, and it is G, G, C. And so what I want you to do is pause this video, and I want you to figure out what the amino acid is that would go with the next three the next three codons. And once everyone has that, then you can resume this video. Okay, so if you were to go through and do this, then you should find that you have THR, and this should say stop. Okay, so you should have gotten glycine, GLY, for GGC, and you should have gotten threonine, for ACG, and then you should have gotten a stop codon for UAA. Okay, so that's basically how this messenger RNA table works. Okay. All right, so now we're going to start on a project that is going to hopefully reinforce how this table works, and again, kind of continue us through this protein synthesis production. All right, so what I have here is we're going to be using poems that are written by my favorite poet, which is Shel Silverstein, and he writes children's poems, silly children's poems. And one of the things that we're going to see in here is we're going to use this table in order to decode the poem. The poem is written in DNA. And so what we will see is that we will see lines that look like this, all right? And there's a couple of things we need to be aware of. The first thing is that there is junk DNA that is embedded within this poem. And so we need to be able to figure out the difference between what we're going to read for DNA and what we're not going to read. All right. And so how that is going to work is that we need to first decode the DNA into messenger RNA. And so we're going to go ahead and do that here real quick. So we've decoded the DNA here into messenger RNA. All right, so now we need to read our codon 3 at a time. All right, and so we are going to go to A, U, and G, which is over here. So we see methionine. Now, in real life, methionine is our start codon. There is only one. Remember, we talked about AUG is August, and that's when we start school. So that's when we start building proteins. All right. So I would write met down. In your case, it will be start. Okay, and I'm going to continue to read my codon 3 at a time. So I get CUA, and so I should get leucine. Okay, then I get to UAA, which should say stop. Okay, now when we are doing sentences, the end of a sentence is a period or an exclamation point or a question mark. And so when you get to a stop of a sentence, you need to stop coding. All right, the key here is that we need to make sure that we continue to read 3 at a time, and we're going to continue to read and get till we get to another start codon, which is going to be AUG. Now the problem is that our initial instinct is to use this as my AUG. Okay, the problem though is that if I continue to read in groups of 3 for my codon, that AUG is not AUG, it's AAU and it's GGG. So again, every time you go through, you want to make sure that you're sectioning off the information in groups of 3. So here I have AAU, nothing gets coded there. I have GGG, nothing gets coded there. AUG is my start codon, so I will start. Okay, so again, we're never going to start until we get to a start codon. Okay, so we're going to have fun. Your poem is due tomorrow. You have the rest of the class to work on this. You can please feel free to review this information. It is posted on Google Classroom. Keep in mind that your poem is a silly children's poem. However, it should make sense once you start to read the sentences. The sentences will go sometimes a couple of different lines, so just because you get to the end of the line does not mean you are at the end of the sentence. The structure should look like this below, where you have on one line you have the messenger RNA, and then the second line should be the words or the amino acids. Okay, and then you're going to skip a line, and then you will do the next whatever many number of messenger RNA codons that you need to do, and then the words underneath it. And so you will continue on in that pattern. So I hope that makes sense, and here's some answers to both of the poems so that you make sure that you are on the right track. Okay, one of them starts with start. Mama said I'd lose my head if it wasn't fastened on. And in this poem, you should see a guy sitting on his head in the poem. Okay, the second poem does not have a picture to it. It should say start who, period. Then it should read start who can kick a football from here out to Afghanistan? Question mark. All right, have fun with this, and we'll see you when I get back. Thank you.